maybe.
There we
Did I
go.
leave it?
There we go. Sorry.
So we have already talked about at this point graphing equations of lines. So we're going to practice with graphing. We're going to take a look at a couple of different equations. What you have in front of you is a worksheet. As I write up the equation of the line, you're going to write it for equation 1, and then I'll put up a second one as well and do equation 2. And I'll have you graph both. We'll go through the first one together as far as graphing for a refresher. Each one of the lines on the graph is just 1. So when you're graphing, it's going to be 1 for each line. So you should have y equals 2/3 x plus 3, and y equals negative 3/2 x plus 3.
That's equations 1 and 2.
So you're going to write down equation 1 and equation 2. And just for some practice with how to graph. When you have an equation of a line, you need at least 2 points to be able to draw your line. What I would do is start out with the y-intercept, which is 3 here, so we know that we at least have 1 point. That's at 0, 3. And then from there, I would use my slope to get the second point. And the slope is go up 2 and to the right 3. The reason why you all have a ruler is so you can draw a straight line to connect your points. We'll pretend like I have a ruler. So this will be my first equation. Once you have your first equation on that same grid, you're going to graph your second equation. That one has the same y-intercept, you'll notice. So it's still 0, 3, but our slope is different. We're going to go down 3 and to the right 2. Once you have both of your lines graphed, you're going to use your protractor and measure the angle degree for those lines that intersect. At what degree do they intersect? And you're going to record that on your paper for angle of intersection. Once you find that angle, can you tell me what you found as your angle of intersection? I got 90 degrees. Very good. Did you find the same thing?
Got about 85, 89 or somewhere, 80.
You're close to 90 still?
Yeah.
That's good. Okay. Now that you've got that angle of intersection, what are some similarities that you notice between those two equations that you just graphed? What are some things that are the same between the two?
The y's are the same.
Your y-intercept, you mean? Is the
Oh,
same?
no, just the y's.
just the y's.
The y equal and the y equal.
Yeah, that's true. We have two different equations that are set equal to y. Anything else that you notice is the same?
3.
And 3 is what part of your equation? If we're talking about slopes and y-intercepts, what does 3 represent?
The y-intercept.
Right, very good. So your y-intercept is the same for both. Look at those slopes. What do you notice about those slopes?
They're different.
So what are some differences? What would you say is different about them?
One's positive and one's negative.
We've got opposite signs, positive and negative. Any other differences?
One is a flip of the other one.
Yeah, and what do we call that when we flip the numerator and the denominator?
I don't know.
Do you know? It's called the reciprocal. That means that we flip the numerator and the denominator. Alright, very good. Anything else you notice? Good start. Let's do our next one then. And this time I'm not going to graph it with you. So if you've got any questions about how to graph it, let me know. So we've got y equals negative 1/2 x plus 4, and y equals 2x plus 4. Give you some time to graph that. Once you get your lines graphed, again, measure that angle of intersection and let me know what you find that angle measurement to be. What are you finding yours to be?
I got 90 degrees this time.
90 degrees?
90 degrees, same.
Okay. What about similarities between those two equations?
The y-intercept again.
Yeah. Y-intercept is 4 again. It's the same. Any other similarities? How about differences?
Slopes are different again.
In what way?
One's the negative of the other and flipped.
So the opposite signs again for our slopes. And then we have the reciprocal slopes. Okay, so you should be noticing some patterns, but let's do one more before we talk about what patterns you're seeing. time we have y equals negative 3/4 x plus 1, and then y equals 4/3 x plus 1. This time again, tell me what you find to be your angle of intersection.
Right at 90 again.
90? Alright. Did you get the same, Miranda?
Mm-hmm.
Awesome. And then what again are some similarities?
Your y-intercept.
Yeah, again, y-intercept is the same for both. What about differences?
Slopes again.
Mm-hmm.
Negative reciprocals.
Negative reciprocals. Right. All right, so we've gone through and we've graphed 3 different sets of equations and talked about the similarities and differences. Do you notice any patterns between those 3 sets?
Y-intercepts are all the same.
Yeah. What else?
Slope.
The slope? Being a negative reciprocal? What about that angle of intersection? Is there any pattern with that?
They're all about 90 degrees.
Mm-hmm. Do you remember when we were talking about intersecting lines, what type of line that would be if they intersect at 90 degrees?
Perpendicular.
Mm-hmm. Right, very good. So these have all been perpendicular to each other. So if you had to come up with a rule for creating perpendicular lines, what would you say that rule would be?
All the lines have the same y-intercept with each other and the same slope, and slopes would be negative reciprocals, and they would be perpendicular.
Right, very good. And that's exactly what our definition is going to be. So for two equations to be perpendicular, their y-intercept has to be the same, and their slopes must be negative reciprocals. So now that we kind of know how the perpendicular equation should be, can you come up with one of your own? One set of two equations that are perpendicular. So what were your equations?
I did y equals negative 1/3 x plus 2.
And your second one?
Y equals 3x plus 2.
All right, so what do we think? Would these be perpendicular? They would, right, very good. So we've got both the same y-intercept, and then we have the slope is the negative reciprocal. How about yours? What would you say yours were?
Mine was y equals 5hx minus 2. No, wait, minus 5hx minus 2. And
Okay.
y equals 8/5 x minus 2.
What do you think about that? Got the same, even though it's negative, it's still the same y-intercept, and then our slopes are negative reciprocals. Very good. So what questions do you have?